Hello everyone, welcome to today's video in thin and thick cylinder. Today we'll see about the longitudinal stress equation, and also we saw cylinder. Next we'll be seeing spherical shell, thin spherical shell. So in the last video we saw the concept of both circumferential stress and longitudinal stress, and we saw the equation of circumferential stress. Now going to the equation of longitudinal stress. So this is the diagram. When the cylinder is cut like this, the pressure force because of fluid will be acting throughout the cylinder, and here it is cut because of this fluid pressure comes into two parts, and taking this part of cylinder, if we are looking like this, we will see the thickness of that circle along which it is cut, and inside it is hollow, but as we are looking from here, this is solid portion, we will see it like a circle. Same for here also. As the fluid pressure is acting like in this direction, in this part, the resistance generated in the material, that is, in order to resist this force, resistance will be generated in the material due to longitudinal stress, and it will be acting in the opposite direction of fluid pressure because it is a resistant stress. So to find that resistant force, that is this P, force because of fluid pressure. First we are going to see about force because of fluid pressure, that is P, where it is acting, the circular area. When we are looking from here, we can see the circular area on which the fluid pressure is acting. See this, we are looking from here, this fluid pressure is acting in this circular area here. Fluid pressure is acting. So P into area of the circle, that is pi d square by 4. Now resistant force due to this longitudinal stress, which is a resistance to this pressure generated in the material along the thickness. So when we are looking this thickness, along this thickness of the circle, it is acting outwards, opposite direction of fluid pressure. So sigma, you can take it as sigma 3. Sigma 3 is the longitudinal stress. Sigma 3 into perimeter of the circle, that is pi d. Perimeter of the circle, pi d, into thickness of this perimeter. Look at this, thickness of this perimeter, T. When we equate both, we will get pi d square by 4 into P is equal to sigma 2 into pi d into T. When we cut pi and d, we will get sigma 2 is equal to Pd by 4T. So sigma 2 can be written as half of Pd by 2T. What is Pd by 2T? It is sigma 1. So half of sigma 1 is sigma 2. The sigma 1, what we got, it is Pd by 4T, and sigma 3 is also, sigma 3 is Pd by 4T and sigma 1 is Pd by 2T. This is longitudinal stress, and this is, so sigma 1 is hoop stress and sigma 3 is longitudinal stress. Here we can see that sigma 1 is greater than sigma 3. So that means what? Sigma 3 is in safer zone. So sigma 1 will be greater. So sigma 1 should not be greater than permissible stress. Why? Because sigma 3 is already less than sigma 1. So we have to need to only be careful about sigma 1. Should not be greater than permissible stress. Now what is tau max? Tau max is equal to sigma 1 minus sigma 3 by 2. That is major principal stress minus minor principal stress by 2. Here sigma 1 major is Pd by 2T minus Pd by 4T by 2. What we will get? It is Pd by 8T. If suppose in the question maximum permissible stress is given, then take it as sigma 1. Okay. And now we will see maximum principal strain, which is E1. And we know the formula, which is sigma 1 by E minus mu sigma 3 by E. Okay, sigma 1 is this one, sigma 3 is this one. Similarly, minimum principal strain is E3 is sigma 3 by E minus mu sigma 1 by E. So, we'll take a thin cylindrical shell. Okay, consider it as a shell, sphere, and it is cut like this. Okay, due to the fluid pressure inside acting throughout the circumference, that is pressure acting like this, it gets split into two parts. Okay, so pressure is acting like this upward throughout the circumference, pressure is acting like this downwards throughout the circumference. Due to this upward force, it is going upward, separated upward, and this one downward. So when we are taking this one and we are looking from top like this, we will see this thin perimeter of the circle, and inside is hollow portion but bottom is solid. So when we look down, we will see what? A circle with this thickness of a perimeter along which it got separated. So this pressure, when we look from top, we will see it as acting on a circle of area pi d square by 4. So in order to resist this pressure, a resisting force is generated in the material due to the stress which is acting upward in order to resist this pressure. So the resisting force due to this stress, okay, which is acting in opposite direction of pressure along the thickness, that is perimeter of circle, that is along which this got separated, along that this stress is acting. Okay, so we'll take a like before itself, the force due to the fluid pressure P is equal to P into pi d square by 4, and now the resistant force generated in the material due to the stress sigma 1 is equal to sigma 1 into along this one, no? So pi dt. We are equating the both, we get pi d square by 4 is equal to sigma 1 pi dt. Sigma 1 is equal to pd by 40. Here both sigma 1 and sigma 3 will be same because it is spherical shell. When it is cut like this or like this, it will be same only. So sigma 1 equal to sigma 3 equal to pd by 40. And what is strain? Strain is sigma 1 by E minus mu sigma 2 by E. Here in this case, sigma 1 and sigma 2 will be same. So E1 equal to E2. So that is about the spherical shell. Thank you.